Alright, example number one, review of conic sections. We have a general conic equation. First thing to look at is that both x and y are squared. They have different coefficients, have different signs. That makes this conic a hyperbola. Ultimate goal for most of these conic equations is to complete the square. Before you start completing the square, let's go ahead and group our y's together. 16y squared minus 64y. And let's group the negative 9x squared minus 54x. And also, let's move the constants to the other side of the equation. Now, before we start completing the square, let's go ahead and factor out the coefficients from the squared terms. I have 16y squared minus 4y minus 9x squared plus 6x. Just be careful right here, negative 9 times a positive 6 should yield that negative 54. Now we can start completing the square. I have 16y squared minus 4y plus negative 4 divided by 2 squared, part of the process of completing the square, minus 9 parentheses x squared plus 6x plus positive 6 divided by 2 squared equal 161. I am underlining this right here to emphasize that I added that, and so to maintain equality I have to make sure that I add it to the other side. Now there are 16 of these in front when we factored it out, so make sure that you add 16 of these to the other side. Now just be careful here, there's a negative 9, you also have to put a negative 9 over here, plus 6 divided by 2 squared. And here you maintain equality on both sides of the equal sign. Now let's go ahead and complete the square. Completing the square, these three terms will collapse to y minus 2 squared minus 9. Again, these three terms, x plus 3 squared. Now these right here, just perform the calculations using a calculator, you should get 144. Standard form does require it to be equal to 1, so let's divide by 144 to maintain, or to get this equal to 1. Reducing the fraction 16 over 144, I should get 9 minus x plus 3 squared over 16 equal 1. And at this stage, we have the standard form equation for this hyperbola. So we can start with the sketch of this. Now it is useful to have grid paper when you are graphing these. First thing you want to do when you're graphing, let me just go ahead and leave the standard form up, is to locate the center point. Again, in center point, you need an x and a y. Go to the x, I have a plus 3, so the opposite of that is negative 3. Go to the y, there's a negative 2, opposite that is a positive 2. Let's go ahead and plot this point, negative 3, comma 2, and let's label center point. Next thing to look at is underneath the y squared term you have a 9. Take the square root of 9, you have 3, indicating to you that you're going to move 3 units along the y in both directions. Same process for the x. Underneath the x you have 16, square root of that is 4. Move 4 units along the x in both directions. Now if this were an ellipse, you would create your ellipse. However, we had mentioned from the beginning that this is a hyperbola. So what you have to create is a rectangle. Now just make sure that throughout this process, initial process, that you do use dashed lines, because this is not part of your hyperbola yet. These are only going to help you establish the boundaries for your parabola. From corner to corner, create a diagonal, extend it outward. When you're doing this manually, it might be beneficial for you to use a straight edge or a ruler. Okay, just remember that these are your asymptotes for the hyperbola. So I'm just going to go ahead and label them. let's be specific. Let's call this 1. Let's call this asymptote 2. Now, next thing to look at is from standard form. Don't get that confused with the general form up here, where you do have y squared and x squared, but you want to look at standard form. Look for the one that is positive. In this case, it's y, the one that is positive. So this hyperbola is going to open along the y direction. For that to happen, let's make these the vertices. And let's just go ahead and create a hyperbola. Let's make this a little bit closer to the asymptote. Just remember that the asymptote is there as a boundary. It should not cross, or your hyperbola, that is, should not cross that asymptote. Pretty much done with the sketch at this point. Now we just have to, based on the geometry of the sketch, let's go ahead and find the information that we need. I know these are your vertex points, so let's label these. And let's go ahead and get the information. Again, based on the geometry, vertex point, I'm simply going to get the coordinates of that. Here I'm at -3, 1, 2, 3, 4, 5, so -3, comma 5. And I have another vertex down here at -3, -1. No formulas there, just using the geometry. For the foci, you do have to use a formula, c squared equals a squared plus b squared, where the a squared and the b squared are what is underneath the y and the x. I have 9 plus 16, remember that they're already squared. C squared is equal to 25, which yields c equals to 5. Now, based on the geometry, again, your foci have to lie inside the parabola, kind of like we were studying on parabolas, rather, because in this case we're looking, it's kind of like we're looking at two parabolas opening in opposite directions. So the foci have to lie inside the parabolas. So from the center, go 5 units. And the reason why I knew I had to go, up, as opposed to if I went this direction, I would plot a point here, but there's no parabola on this side. Same thing here, 5 units down, and let's go ahead and label this. That way we know that they are the foci. And again, same thing as the vertices. From the geometry of the sketch, just give me the coordinates. You're at -3, 1, 2, 3, 4, 5, 6, 7. -3, 7. Or simply, we're moving along the y. From this point, from the vertices, from -3, actually, from the center, from the center, you're going to move along the y, 5 units, so add 5 to here, we get that 7, and -3 subtract 2, kind of like we're going down, 5 units, we end up at -3. Again, it's useful to just kind of get the coordinates based on the geometry, -3, -3, -3, 7. Okay, the last thing is going to be your asymptotes. I am going to require a point slope formula because I do need the equations for these two asymptotes. Starting at x2, x1. Now the slope is just simple, rise over run. For the asymptote 1, choose any 2 points. Rise is 3, run is 4, 3 over 4. Slope over here, I'm going to choose this point, that point down here. Rise -3, run is still +4. I like to use center point as the point of selection because it is contained in both diagonals. That way I just use the same point for both the equations. Let's start with asymptote number 1. I have y minus 2 equal, again, asymptote 1 had the positive slope, 3/4 x minus -3. Now, asymptote 2 is going to be similar process, y minus 2 equal -3/4, that's slope, x minus -3. And let's just go ahead and get rid of that double negative, x plus 3. y minus 2 equal negative 3/4 x plus 3. At this point, you can leave these equations in this point slope form, or if you want to change them to y-intercept form, sorry, slope intercept form, just simply solve for y, perform the algebra and solve for y. There you have the graph and the pertinent information for it.